everyone, and we welcome you all in CDTI. CDTI, it's a governmental organization for research and development and the promotion of industry and industrial activities as a whole in Spain. But in particular, today we are talking about space activities, and we are the Spanish representatives in the agency, and also in the Spanish. We are the Spanish representatives in the Horizon 2020 research program committees. So we are the focal point for institutional representation of Spain in space activities. Having said that, today it is not of. It is a different matter because CDTI is participating in some programs under the umbrella of the European Union funding and in the Horizon 2020, mainly three of them: electric propulsion strategic research cluster with the project EPIC, which is today's subject, strategic research cluster space robotics in Peraspera, and space surveillance and tracking of space debris in orbit and their possible damage on Earth. But today we are talking about electric propulsion. Welcome you all to in Spain. The lectures are going to be in English, although I speak broken English or strange English for some of you. Lecture series is about that. I am going to skip this part for a possible edition, but the first electric propulsion, you know very well, was Spaceship Enterprise. And also I've heard that Tintin use atomic engine just to power its electric propulsion. And in Star Wars, you see that this Shannon propulsion coming out from the battleship. So it was a long use for many years, and of course this is a joke. But why we are doing these activities in CDTI? Because we are participating in the strategic research cluster activities of electric propulsion and the European Union, and one of the main important tasks is education. So this is an educational activity of this project, and the objective of today's lectures is to give important and interesting lectures to engineering universities, bachelor's, science students, just to give from basic technologies to latest developments on electric propulsion and related matters. This lecture series has been organized by EPIC, in which CDTI is a partner and under the leadership of ESA, by the University Carlos III of Madrid, and also with some collaboration of the Polytechnic University of Madrid. Which is the objective? To cover different subjects from basic electric propulsion concepts, physics, we will cover several basic models, grid ion engines, Hall effect thrusters. We'll cover measurement techniques, examples of missions on which the electric propulsion has been used, and also we'll see some possible missions for the future, because you will understand and you will learn that electric propulsions enable new missions that cannot be made in space with classic propulsion. Today's invited guest lecturers came from different origins, different places. We have people, very important people today in giving the lectures, from ESA, European Space Agency, from Airbus Defence and Space, the biggest space prime in Europe and in the world, I should say. people from CRISA, from Spain, also part of Airbus Defense and Space, but specialized in electronics, space electronics, and in particularly in electric propulsion in PPUs. People from the university, from Polytechnic University of Madrid, with a lot of expertise on testing and measurement techniques. Also, we have people from industry abroad, from Kinetic Limited. They are the experts in grid ion engines in Europe. And also, very important, we have with us the University Carlos III of Madrid, which is a reference in Europe and in the world on many things about electric propulsion, from simulations, from understanding the physics, to developing new thrusters, new disruptive thrusters, to many other disruptive subjects such as magnetic nozzles. Also, we have with us today people from ONERA, a research institution in France, extremely important, extremely well recognized and known in south of Paris, given the flavor of the latest developments in RF plasma sources. And these are the names, these are the subjects of their presentations. But you may think, why electric propulsion? You have a normal propulsion, why electric propulsion? Electric propulsion is really, really a key new strategic technology. It is not so new. It has been there since a long time. But now we are living really a revolution, because now we are starting to use widely the electric propulsion in space. In size, in telecommunication commercial market, in small satellites, in CubeSats, it's everywhere. And we are showing now really and proving their really advantages. The biggest advantage is that it's a propulsion system that has very high specific impulse. So specific impulse is the amount of thrust you can get from a kilogram of fuel. And if you are very efficient on that, this means that either you bring less propellant for the same total impulse, from the same thrust, therefore you have more space for the mission, for the payload, for whatever, or then you can use a smaller launcher, and then there is a big impact in cost. So higher specific impulse means reduce cost or increase your mass for your payload. The drawback is that you have little thrust. So unfortunately, we cannot get into the orbit with electric propulsion. But okay, we have the rocket guys. They do this job quite well. So we use electric propulsion in space when we are in orbit. And I can tell you, we are going to use it for a lot of things. And not only because it's going to be cheaper for the missions and it's going to be is a driving factor to save mass, because also very important for exploration, for some exploration missions, it is the only way to reach some planets, to do some missions. It is really, really the only way. You cannot use chemical in some missions. Okay, I will not go into details. We have the experts with us. Let's come to the logistics and to today's details. Don't use Wi-Fi today. Don't use your mobile. Be really here with us. But if you have to, this is the Wi-Fi code, okay? Use it if you need it only. We are at CDTI ground floor. This is the auditorium. The coffee lobby is outside, okay? And the toilets are over there. Registration you just passed by. Other areas in CDTI are off limits, okay? So stay here. If you have to go out for lunch, of course, keep your badge. Show it when you will come in and you will be accepted, no problem. After the day, return the badge, okay? Okay, the first 2 rows are reserved, but okay, feel free, we are not full up. We will start all sessions on time, so coffee breaks, come on time, please. Coffee breaks will be provided, no problem, but lunch will be on your own. And we will be very pleased to send you by email to the ones attend, or to the attendees, an attendance certificate, okay? Because if you want to pass the exam, Eduardo, you will have to also show the certificate and pass the exam. So be very, get everything. Okay, all presentations and the video, which is performing of the introduction section and of each of the lecturers will be available on the web. So we have a YouTube channel. You will be able to see it again and prepare your exam. Okay, no problem. Follow us on Twitter. Okay, make us racing in the likes. Perfect. Please, if you have a mobile, switch it off or mute it. Okay? Thank you very much. That's all. And now, Eduardo Aedo, professor of the University Carlos III of Madrid, is going to introduce and inaugurate the lecture series. Thank you.
Okay. Good morning, everybody. Welcome to this event. Thank you for attending, to all of you, but especially for the university students that you are here, because this event, this lecture series, are being designed for you, for university students. I know that you are very busy, so we appreciate very much that you have found time to come here now that you are in the middle of your academic term. I want to congratulate EPIC on the EPIC project, and in particular Jorge, for bringing up this initiative that we think is very important. Jorge has already explained the importance that electric propulsion is having. So dissemination of this activity among you, university students, that you are going to take the witness from us in a few years, is very important for us. Okay. I want to thank also EPIC for inviting my university, Universidad Carlos III, to co-organize this event. Okay. This first edition of this lecture series, we are going to have another 2 editions. The next one is going to be in London, and the third one in Aztec, if I am not confused. Let me briefly explain what is University Carlos III, why we are here. We are a young public university with 4 campuses in the Madrid area. And it's a multidisciplinary university. We have studies of law, economics, social sciences, humanities, and engineering. The campus of engineering is in Leganés. It's a suburban city, 20 minutes from here. And there are about 8,000 students studying the bachelor, master, and PhD degrees in engineering. We have aerospace, we have telecommunications, we have energy, computer science, and biotechnology. So all of them are quite relevant for space technology and space science. Okay? I am in the Department of Aerospace Engineering. Within that department, there are 2 research groups that are devoted to space. Okay? One is the Plasma and Space Propulsion team, that is my team. And then there is the Space Dynamics, Optimization, and Control. In total, we're about 20 people. So it's a group where we can do a lot of things. As teachers and researchers in electric propulsion for 20 years, I can confirm what Jorge was explaining, that electric propulsion is experiencing a spectacular growth in the last years. Okay? Electric propulsion is no more a marginal or a tomorrow solution. Is now on the edge of taking the leadership for propulsion in a space of a spacecraft. Okay? From chemical rockets. This leadership ranges from the conventional geosatellites, mainly for telecommunication, to deep space probes and satellites, as Jorge commented, but also in the new space, the so-called new space technology, like the large mega constellation that are now on the news. Okay. This does not mean that chemical rockets are dead, not at all. They are still needed for fast maneuvers in space, and they are, of course, needed for launchers. Okay, the launches of satellites will be is going to be continue to be made by chemical rockets. Okay. You may be thinking that this technological change from chemical to electrical propulsion is comparable with the one that is happening now with cars. Okay, it's partly true, but the change is much more advanced in a spacecraft than in cars. Okay. Another point is that electric propulsion constitutes a large family of devices. We have mature devices that are already flying, and then we have also several experimental devices, some of them very exotic. Some of them will never get the way to fly, okay? But we are experimenting with different solutions, trying to improve in several aspects, from the lifetime, from the simplicity of the system, from the thrust we can get. So the role of the speakers of this lecture series is to try to convince you of this statement, to show you this statement, and at the same time to provide you some insights on some of the technologies. Okay, we have only 8 lectures. The afternoon lectures are devoted to technologies, so we have selected 4 technologies. Other ones will have their place in the next edition of the lecture series. Okay. So who are the speakers? We must acknowledge that there have been a bit bias on the selection of the speakers here, partly because of logistics. Okay, and 6 of the speakers we are Spanish. Okay, and we thank Vincent Jacob and Denis Pagan, 2 great French colleagues, for completing this group of speakers. Okay, but beyond logistic, the intention was also clear. Most of you come from the universities in the region of Madrid, okay? So you are Spanish students. And we want to send the message that electric propulsion is not a foreign technology, let's say, okay? It's a technology where the Spanish institution, the Spanish university, and Spanish individuals, we are highly involved in their research and their development, okay? So it's a place where you can be very welcome in the future. Okay, we need fresh and enthusiastic minds to bring to a full development of this all-electric propulsion technology. So you will be much welcome on board of this odyssey. Okay, so thank you very much and welcome again.